Hello everyone, welcome to my YouTube channel. In this video, I am going to explain Class A series fed amplifier efficiency analysis. Okay, this is the basic circuit diagram of a Class A series fed power amplifier. So here output is taken at the collector and input is applied at the base. So that means it is in basically a common emitter amplifier. Here fixed bias circuit is used. So a power transistor is used. That means which can handle large amount of power. Okay, power amplifier is basically a power converter which converts DC input power into the AC output power, whose action is controlled by this applied input signal. That is the basic concept of power amplifier. Anyhow, this is a class A amplifier. Conduction angle is 360 degrees. That means transistor is operated at the active region. Transistor is operated at the active region. So before going to the derivation, we have to understand the concept of active region and load line analysis. Okay. So load line is, so I will draw this line. Load line is the line drawn between the saturation point and cutoff point. This is the saturation point. This is the cutoff point. So basically the amplifier is connected in CE configuration. The output of CE is VCE and output current is IC. Output current is IC. So the maximum current is at saturation, maximum voltage at cutoff point. Okay, so to get 360 degrees conduction angle, operating point is located at the middle of this load line. Middle of this load line. This is called the active region. Suppose if operating point is located at this region, so we'll get 360 degrees conduction angle. 360 degrees conduction angle. This is 360 degrees conduction angle. 0 to 360 degrees conduction angle. Okay. So similarly current also. You get 360 degrees conduction angle. Okay. So but what is the value of voltage at cutoff region? What is the value of current at the saturation region? This is very, very important. Just observe the circuit diagram. Okay. So here VCC is applied with the help of collector resistance RC. So VCC is applied here. So it is grounded. Emitter is grounded. So the voltage between the collector and emitter is called VCE. So applying KVL to the output portion of the circuit. This is only output portion. Applying KVL at the output portion of the circuit. So we'll get VCC is equal to ICRC plus VCE. ICRC plus VCE. So I want IC value. IC value at saturation point. At this point, IC value. So at this point, observe the VCE value. VCE value is 0. So put VCE is equal to 0. IC is equal to VCC by RC. So VCC by RC. Similarly, at cutoff point, at this point, put IC is equal to 0. Current is equal to 0. Therefore, VCC is equal to 0 into RC plus VCE. So VCE is equal to VCC. VCC. So this is VCC. So the maximum value is VCC. Minimum value is 0. Minimum value is 0. So minimum value is 0. Here also maximum value is equal to IC. IC. That means I maximum. This is equal to 0. I minimum is equal to 0. So this is very, very important to derive the efficiency of a class A series fed amplifier. Okay. Now the slope of DC load line. That is also very important, especially in class A transformer coupled amplifier analysis. So the basic equation is VCC is equal to IC into RC plus VCE. So IC into RC is equal to VCC minus VCE divided by RC. So, sorry, IC is equal to VCC minus VCE divided by RC. By rearranging this equation, IC is equal to minus 1 by RC into VCE plus VCC by RC. సో అది చెప్తున్నాను, జాగ్రత్తగా అబ్జర్వ్ చేయండి. ఓకే, దిస్ ఈస్ ద బేసిక్ ఈక్వేషన్, output portion of the common emitter configuration. So from this equation, IC is calculated, VCC minus VCE divided by RC. So here minus VC by RC ni minus 1 by RC into VCE and RC plus VCC by RC. So rearranging this equation, we get this one. Okay, so VCE, output voltage in common emitter configuration, x-axis comp, and VCC by RC. VCC is a fixed voltage, say 5 volts, 9 volts, or RC is a fixed resistance, so it is a constant. So IC on y-axis, this is y. So minus 1 by RC is nothing but slope of DC load line. So this is the slope of DC load line. So slope of DC load line is equal to minus 1 by RC. This is very, very important, especially in transformer coupled class A amplifier analysis. Okay. Now coming to the derivation, efficiency derivation. So efficiency is equal to output power by input power. What is output power in class A amplifier? AC output power. What is input power in class A amplifier? DC input power. Why? Because power amplifier is basically a power converter which converts DC input power into the AC output power. Okay, so it is a large signal amplifier, so H parameter analysis is not applicable for power amplifiers. Again, I will redraw the load line. This is okay. So here operating point is located at where? Q. That means operating point is located at where? Active region. So maximum swing is possible. Maximum swing is possible. What is the maximum point? VCC at cutoff. Minimum point 0. Similarly, current at the operating point is ICQ. So here also maximum swing possible. Maximum swing possible. So this is I maximum. I maximum. This is I minimum. That is equal to 0 under ideal conditions. Okay. So how to calculate AC power? AC power is equal to Vm divided by root 2. Because of RMS value, here root 2 is considered, into Im divided by root 2. So Vm into Im divided by 2 is the AC power. AC power is equal to Vm into Im by 2. RMS కాబట్టి ఇక్కడ root 2 value తీసుకున్నాం. Okay, మరి how to calculate Vm? So for example, assume this is a sinusoidal signal. Okay, right? So this is V maximum. So this is V minimum. V minimum. So peak to peak value is equal to V maximum minus V minimum. V minimum. Okay, but I want only Vm value. Vm value, this one. This is a Vm value. Up to this one, Vm value. So this is Vm value. Okay, therefore Vm is equal to V peak to peak divided by 2. Okay. Similarly for current also. Okay. This is current, for example. So this is equal to I maximum, this value. This is I minimum. So I peak to peak is equal to I maximum minus I minimum. But I want Im. So Im, this one is equal to Im. Only this portion Im. Okay. So this is Im only. Im, not maximum value. So therefore Im is equal to I peak to peak divided by 2. Okay. So substitute these values in the equation. What is the basic equation? TAC is equal to Vm into Im by 2. Vm by root 2 into Im by root 2, that is equal to Vm into Im divided by 2. So Vm is equal to V maximum minus V minimum by 2 into Im is equal to I maximum minus I minimum by 2 divided by 2. So overall this 2 divided by 2. So ఒకసారి మళ్ళీ చెప్తున్నాను, Vm is equal to V maximum minus V minimum by 2. Okay, Im is equal to I maximum minus I minimum by 2. Overall divided by this 2. So finally PAC is equal to V maximum minus V minimum into I maximum minus I minimum divided by H. Divided by H. What is the V maximum? Just observe this graphical representation. What is the V maximum? This is the V maximum. V maximum. This is the V minimum. V minimum. So what is the V maximum? VCC. V minimum is equal to 0. So substitute these values. V maximum is equal to VCC and V minimum is equal to 0. I maximum is equal to IC. I minimum is equal to 0 divided by H. So that is equal to VCC into IC divided by H. Okay, but just observe this graphical representation. IC, I maximum is equal to IC. So IC is equal to 2 into ICQ. What is ICQ? This ICQ is the collector current at active region at operating point. So for example, assume the I maximum is equal to 10 milliamperes. So I minimum is equal to 0. 10 minus 0 is equal to 10. ICQ is exactly middle of the operating point, is exactly middle of the load line. So the corresponding current ICQ is equal to exactly half of the maximum current. So ICQ is equal to 5 milliamperes in this example. So therefore IC is equal to 2 ICQ. So I will substitute this value in this equation. So VCC into, instead of IC place load, 2 ICQ, substitute 2 ICQ divided by H. Therefore PAC is equal to VCC into ICQ divided by 4. That means 2 ones and 2 fours. Okay, right? Similarly, DC power. How to calculate DC power? PDC is equal to VCC, applied input voltage, VCC, DC voltage, into current, ICQ, current at the operating point. Therefore, efficiency is equal to PAC by PDC, that is equal to VCC into ICQ, this is PAC, VCC into ICQ divided by 4. So VCC into ICQ divided by 4, again divided by PDC, VCC into ICQ. So that is equal to VCC into ICQ divided by 4 into VCC into ICQ. So ICQ cancel, VCC cancel, we'll get 1 by 4. Efficiency in percentage, that is equal to 1 by 4 into 100, that is equal to 25% efficiency. So this is the series fed class A amplifier analysis. Thank you.